Today we're going to look at the chemical process called cracking. I'm going to build up a mind map. It will be worth you trying to copy down the mind map, obviously pausing the video at points if you need to. Then once we've done that, we'll have a look at some questions and ways that we can use the mind map to help us learn. So you're going to need a piece of paper on its side, so landscape, and in the middle of that piece of paper, if you can write the word cracking. So we're going to look at two things associated with cracking. First of all, we're going to look at why we do it and what happens during the process, and then we're going to look at how we do it. So we're going to look at the why first of all. So cracking is carried out because it turns long chain hydrocarbons which I'm going to represent with this long squiggly line here, and those long chain hydrocarbons are produced during the process of fractional distillation, which we've already looked at. Now we actually produce a lot more long chain hydrocarbons than we need. So we say that the long chain hydrocarbons are produced in surplus. Surplus means more than is required. So I'll just add that there. So that means more than needed. The long chain hydrocarbons are turned into two products. A slightly shorter chain hydrocarbon, not that much shorter. So this hydrocarbon here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 hydrocarbons, carbon atoms long, and it's going to be broken into a chain which has got 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms in it. Now this is really important because these shorter chain hydrocarbons are in demand. That means we need them, and we don't produce as many as we could do, and particularly these 8 chain hydrocarbons as fuels. Gasoline is made up of 8 carbon atoms. But as well as producing a shorter chain hydrocarbon, it also produces a compound called an alkene. We're going to look at the structure of an alkene a little bit later, but for now I'm just going to say that an alkene has got a double bond between the 2 carbon atoms, and these are really important for making chemicals. So I'm just going to summarise what we've done there. So during the process of cracking, we do it because we're turning long chain hydrocarbons into shorter chain hydrocarbons and an alkene. Those shorter chain hydrocarbons are highly in demand as fuels, and the alkenes are really important in making lots of chemicals. Chemicals like chemicals like dyes, explosives, and many different chemicals that we use in our everyday lives. The long chain hydrocarbons are produced in fractional distillation, and these longer chain hydrocarbons are produced in surplus, which means more than are needed. So how we do this? It's a process called thermal decomposition. Thermal decomposition is made up of 2 words: thermal, which means heat, and decompose or decomposition, which means to break down. So we're just going to add that there, which means breaking down with heat, or breaking up a component with heat. So we actually need 2 things for this reaction to work. Firstly, we obviously need to heat this quite strongly using a Bunsen burner, and then we also need something called a catalyst. Now, a catalyst is something that's going to make this reaction happen much faster but not get used up itself. How this is done in the lab is we have a boiling tube on its side, and into that boiling tube we put two things. We put a catalyst and we put some mineral soaked with a long chain hydrocarbon. When we do it in the lab, we do it with a long chain hydrocarbon called paraffin, and then we heat this very strongly. I'm not going to go into full details of exactly how this is done in this video, because I'm going to attach a YouTube video that shows it actually being done in the lab, so it's a bit easier than me drawing a complicated diagram. And we'll collect over water the ethene gas that is produced, and then we'll need some big tub of water, and then the bubbles of ethene gas over time will be produced and will be collected at the top of this test tube. The final thing we need to know is that ethene gas is tested for using something called bromine water, and bromine water turns from orange or brown to colourless if an alkene is present, or if an ethene is present. So if I just summarise this one more time, then we're saying that how we carry this out is that by a process of thermal decomposition. This means breaking down with heat. We need two things, a heat and a catalyst. In the lab we do this by heating a test tube containing our long chain alkane, in this case paraffin, with a catalyst, and then that produces, by displacing water, ethene gas. We can test for that ethene gas using bromine water, and bromine water goes from orange to colourless if there is an alkene present. The only thing I could add here is that the catalyst that we use in this case is aluminium oxide, and we can get aluminium oxide by using broken pieces of porcelain or broken pieces of pottery. So there's some things that you're going to need to do with this now. Obviously, once you've got your mind map completed, spend a couple of times talking through it yourself in the way that I've done. So I've gone where I've summarised it, I've used my pen, or I could use my finger to trace through the mind map, saying the words as I see them. If you do that 2 or 3 times, that will really help you learn it. I'm then going to give you some questions attached to a PowerPoint which you can have a look at. Hopefully you can see the whole of the mind map now, just so you can summarise it for yourselves. Thank you very much.